absolute value of maximum bounding it. So that's a big property. And it's even easier when you're talking about limits at a single point. So key idea here is f of x, absolute value of f of x, is bounded. So this guy, within this bowl, it's bounded by some maximum value of m, and it's positive because we take the absolute value. So this guy has a smallest value, and also has a maximum value within the bowl. And you can see through this guy. So we know that this guy is less than or equal to, or this guy is less than or equal to, m of g of x minus L plus epsilon over 2 for some positive constant. For some positive constant m. Using that epsilon, that f of x bowl reasoning because of this guy. So, okay, so what can I do here? Very simple, same trick. And now choose this guy, choose any epsilon, and now choose some delta 1, we have delta 1 for it, some delta 1 hat, some special delta 1 function of the epsilon and the x, such that this guy is now less than m, so epsilon over m, over 2. So this guy becomes, can you get the other things? Yeah. So this guy now becomes, and let's separate this guy. Well, let's reveal this. And this guy now becomes, this guy is now, oh, why is there, this guy is now less than or equal to, or not strictly less than, because the epsilon is strictly less than. It's less than, because now we place the, so the m is there. Now we have this guy less than epsilon over 2m minus, or epsilon over 2m plus epsilon over 2. And this guy, remember, so by the way, we chose, since we had delta 1 hat here, delta 2 hat here, we had to choose x minus a. And before we had x minus a less than delta 1, delta 2 hat, right? Delta 2 hat. But now we can choose, now we also need delta 1 hat. It needs to be smaller than delta 1 hat. And the thing is, we had to have it smaller than both of them for both of these inequalities to be true. So we choose x minus 1, x minus a less than the minimum of delta 1 hat, delta 2 hat. So this delta, oh, by the way, we have delta equal this minimum. So it'll be less than these two, causing both of these inequalities to be true. So, because that's all really epsilon delta is causing inequality, choosing the right delta for the necessary inequalities to be true. So this guy's less than m over epsilon over 2m plus epsilon over 2, which is equal to epsilon over 2 plus epsilon over 2, which is equal to epsilon. So therefore it's continuous because if you choose this magical delta, which corresponds to causing these special epsilons to be true. And this guy, we have, by what we have shown, by starting from the beginning, oh, where's the beginning? But you know, this is all one big inequality. I've shown f of x, g of x, minus kl to be less than epsilon. For any epsilon, because that epsilon can be arbitrary, whenever x minus a is less than delta, where delta equals min of delta 1 hat, delta 2 hat. Okay, my class starts at 1, so I gotta get going. Thank you very much. Math Ninja, out!